Hi, I'm Anthony Fodor, and this is a demo of some code that I've recently written using the D3 visualization platform within HTML5. This tree represents the results of a 16S rRNA sequencing experiment in which about 578,000 sequences were classified by the RDP classifier. So the root of our tree here represents all of the sequences. And then we walk down RDP classifications, going from phylum to class to order to family to genus. This is a colorectal adenomas gut 454 sequencing experiment. From human gut, we expect most of our samples to be captured in Firmicutes, Bacteroidetes, and Proteobacteria. The size of these circles represents the number of sequences that are in each taxa, and so our expectation of a dominant community by Firmicutes, Bacteroidetes, with maybe some Proteobacteria thrown in for good luck, is met. Because this is a force tree diagram, actually all of these nodes can be moved. So I can take any one of these nodes and move them anywhere that I want to in the tree, and can restore the tree to its original form by hitting T. I can also release all of the nodes in the tree, and make a true force tree diagram by hitting that reanimate button here. This is a lot of fun to play with. You can move the nodes around and play with them in many different ways. But in general, this view, while it's looks kind of cool, it is not particularly useful. So we usually want to work with the tree in this state. Okay, so let's look at this tree in the context of some analyses. Let me grab the Proteobacteria here and move it around here. And then I'm going to hit the A button. I could also click on this arrange around last selected. And that's going to draw a subtree now around the Proteobacteria. So I've broken out the Proteobacteria from the main tree. If I hit V, I can get rid of everything else and only look at the Proteobacteria. And so that's toggling V. So now I'm going to, and there's a little bit of a refresh bug. You can see the links didn't come back there. I had to resize that, so it's a bug that I need to squash. Now I'm going to take the gamma Proteobacteria out from the Proteobacteria and make another subtree. So now I have one tree that is everything except the Proteobacteria, then another tree representing the Proteobacteria, and another tree representing the gamma Proteobacteria. By hitting the R key here, I can turn this right menu on and off. And obviously, we want to make these menus draggable and resizable, and generally more convenient to deal with. But that's a feature that we haven't implemented yet. Now, as I said, the size of each node represents the number of sequences that is in each taxa. But we can in fact make the size represent any of the metadata that's in our data set. So by clicking here, I now change to the size of each node representing the negative log of the p-value of a null hypothesis of no difference between case and control. So these are experiments between case people with adenomas and control people without adenomas, and the larger the circle, the more that particular taxa was associated with the precancerous growth in our 454 experiment. And so what you can see from here is that there's really different kinds of taxa that you see. So let's take a look now at the Helicobacter here, which is this large circle here. If I hit V here, I toggle everything out except for the Helicobacter. So what we can see is that the Helicobacter was highly significant between case and control. It was highly associated with the presence of cancer. The t-test, the value of the t-test was 10 to the minus, close to 10 to the minus fifth, in between 10 to the minus fourth to 10 to the minus fifth. So we reject a null hypothesis that the Helicobacter is not associated with the colorectal adenomas with a p-value of less than 10 to the minus third, less than 0.001. And what we can see as we walk up the family tree here is that this Helicobacter was not what you see at the genus is what you see when you walk up the phylogenetic tree. You don't see a difference as you go from genus to family to class to order. There's really, and in fact, the number of sequences isn't going up very much either. You have 500 sequences here. You have only 523 sequences when you get to the class level. And if we hit V twice here, we can actually recover some of the other taxa that, besides Helicobacter, that are present, and we can see that there isn't much significance between case and control, and we can switch back to the number of sequences here to show that in fact there's a very small number of sequences in all of these taxa. So this allows us to look at an inference view within our tree, walking up and down hierarchically in an interesting way. If I and again, here's this resize bug that's irritating that I have to resize in order to get the links. If I repeat this experiment, so go to resize this to be the number of sequences, and again grab the proteobacteria, and then again grab the gamma proteobacteria and make this tree, and then again resize by the negative log 10 p-value, we can see a different kind of taxa, which is here. So here is this taxa Spingobium, probably not pronouncing that right, but when you walk up the phylogenetic tree, there's a real difference in inference. So this Spingobium, unlike the Helicobacter, is significant at lower phylogenetic levels, but is not significant at higher phylogenetic levels. And in fact, if we look at the number of sequences here, they rapidly go up. So there's, if we hit V twice here, we see that there's many other taxa, and I can hit A to just rearrange the subtree. We see that there are many other taxa which belong to the family that were classified to different genre, and that's a different case than we have for Helicobacter. So this is a really nice view for giving us a way to think about inference without losing essential phylogenetic information.